Okay, let's just dive right in, shall we? Welcome to this rapid-fire explainer where we are going to uncover a 17th century physics secret. And this is a secret that literally allows you to perform superhuman mechanical feats every single day.
Seriously, think about this everyday mystery for a quick second. You're driving, right? How does a tiny, slight tap of your foot on a brake pedal manage to bring a massive speeding 2-ton vehicle to a complete, screeching halt? It's kind of crazy when you really think about it.
Well, from hoisting up those heavy cars at the auto shop to, tiny medical syringes, or even massive airplane landing gear, the secret behind the magic trick is always exactly the same. It's hydraulics.
And the absolute core of that secret is something called Pascal's law. Discovered by the brilliant physicist Blaise Pascal, it basically says this: because liquids are, well, they're practically incompressible, any pressure you apply to a trapped fluid gets transmitted perfectly, completely undiminished in all directions at once.
Actually, a quick aside here, the guy himself was just wildly fascinating. Before he died back in 1662, Pascal didn't just lay the groundwork for fluid mechanics. No, he also went ahead and invented the world's very first mechanical calculator and, get this, he even laid out the early blueprints for modern public transit. I mean, talk about an overachiever, right?
Anyway, back to the physics. The math behind his law is actually wonderfully simple. Pressure just equals force divided by area. That's it. You're basically taking a push, which is your force, and you're spreading it over the surface area that it's pushing against.
Now, here is the absolute aha moment. This is exactly how the superpower works. If you apply a small force to a tiny area, say a really small input piston, that exact same pressure travels uniformly right through the fluid. But when it hits the other side, it pushes against a much, much larger area.
And that creates a massive, literal force multiplier effect. So if your second piston has, let's say, 50 times the surface area, a tiny 1 Newton push on the small side effortlessly explodes into 50 newtons of lifting output on the large side. You are essentially multiplying your own physical strength. It's like a cheat code for reality.
But wait, you can't just break the laws of the universe, right? To avoid violating the conservation of energy, there is a catch. You gain this massive amount of lifting force, absolutely, but you trade off distance. To lift a heavy car just, say, 2 centimeters with that larger piston, you might actually have to push the smaller input piston down a full 100 centimeters. So the force goes way up, but the distance moved goes down.
And remember, this immense multiplied pressure, it doesn't just push in one single direction. It acts equally, at perfect right angles, pushing aggressively against absolutely all the enclosing walls of its container.
Which perfectly sets up this crazy famous anecdote from 1646 known as Pascal's barrel. So the story goes that Pascal took a long, super thin vertical tube and inserted it into a completely sealed, solid wooden barrel full of water. By pouring just a tiny, tiny bit of extra water high up into that tall tube, the immense hydrostatic pressure acting equally on all those inside walls literally burst the heavy, solid oak barrel wide open. Just from a little bit of water.
It really is an incredible reminder of the invisible, powerful forces at play all around us every day. So I want to leave you with this thought. Knowing how easily fluids can multiply your force and literally burst solid oak, what hidden immense pressures are silently surrounding you right now? Like in every single pipe, brake line, and fluid container you're going to pass by today. Pretty wild to think about.